going to be one side of that handout that we're going to be working through together, okay? All right, but again, you're going to need that purple packet with all of our z-scores, I think. Okay, all right. So on Friday, we talked about that the numbers in this table represent cumulative areas, so areas to the left, and then we talked about we can get an area to the right if we do 1 minus this number, or an area between if we subtract 2 numbers. These values come from taking probability distributions. The total area underneath the curve is equal to 1 because that's the total probability of any given situation, any given experiment. So we can use this table to calculate probabilities of certain things happening. For right now, it's just going to be a probability of a certain z-score occurring. Okay, so the first one, probability of a z-score being greater than negative 1.85. Here's how you would use your table to do this. You're going to find negative 1.85 on your paper. Okay, so negative 1.8 on the left. Make sure you're on the negative side, and then go across the top to 5. Negative 1.85 gives me 0.0322 is the number I get from my table. Okay. All right. Now, it's helpful to kind of just imagine. It doesn't ask you to sketch it here. Negative 1.85 is down here, and we're finding the probability that something is greater than that. So it's like shading to the right. Okay. The number that we have is the probability if my z-score was less than negative 1.85. I want greater than, so we're going to, like last week, use the complement, 1 minus that number. And then you're going to see you'll get an area that makes sense with that sketch we made there. It's going to be most of my curve. It's going to be pretty close to 1. So 1 minus 0.0322 gives me 0.9678. So if I had a data value that represented a z-score of negative 1.85, the probability that I would have that data value or something greater than it would be approximately 97%, so pretty likely. All right, let's look at if we have a probability of a z-score that's less than negative 1.8. Okay, so again, find it on your chart first, negative 1.8. Negative, or 0.18, really small. I get 0.4286. This is the probability that the data value with this z-score, which is just to the left of the mean, will be less than. And because we have a cumulative area shaded there, an area to the left, no adjustment needed, that is our answer. Okay. Probability that we have a z-score between 0 and 0.525. Okay, again, I'm going to make a quick little sketch. A z-score of 0 is where on this curve? A z-score of 0 is where? Where? The middle. It's at the mean. So I could look up that one if I really wanted to on this chart, but I know if I'm at the mean, the cumulative area or area below there is going to be just a 0.5. Okay, so you can say 0.5000. That's what you're going to find on the chart. If you look it up, I think that one's on both sides of our chart. Okay, and then 0.525 is half of the way to that first standard deviation. So something like that we're calculating. That one we're going to need to look up. Now, this one we have to be careful because it gives us 3 decimal places. We talked about this on Friday, so we're going to look at 0.52, and we're going to look at 0.53, and we're going to find what's in the middle of those 2. All right, so positive 0.52 gives me 0.6985. 0.53 gives me 0.7019. And then we need to average those, add them up, divide by 2. This one's not quite as pretty as the ones we did last week. I get 0.7002. Okay, so we have cumulative areas up to both of those numbers. We want to calculate the probability that we're between them. So if you remember from Friday, Just bring that data down. We did the bigger one minus the smaller one, and my final answer here is going to be 0.2002. Okay. Any of these, depending on how the problem's worded, like in Math Excel, you might be, because they're a probability, giving it as a percentage. That's what all these are representing, remember. So just going to move that decimal 2 spaces over if you need to. Okay, so a little review from last week. Any questions there? Okay, so now we're going to put that together with something that we learned back in chapter 2. This is a review formula. If you want to put it in the corner of your sheet somewhere, you can, just so you have it. So in chapter 2, we learned how to calculate a z-score. We could take any data value x, and we could figure out where it's going to be on that normal curve using this formula. We took the x value minus the mean, and then we divided by the standard deviation. And this is the formula written with population variables, but remember it could be written with, instead of that mean symbol that you see there, with like an x bar if it's a sample, or an s for standard deviation if it's a sample. Okay, so we're going to use this now. So putting two things together, we're going to take an x value, we're going to convert it to a z-score, and then we're going to use that to find the probability with our charts. All right, so a national study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. A college student with a job is selected at random. Find the probability that a student works for less than 4 hours per week. Assume the lengths of time college students work are normally distributed and represented with a variable x. Okay, so I'm going to just kind of pull from this information all the important things it's giving me. And we're going to be doing this a lot over the next few chapters. This is kind of like the building blocks of a bigger thing that we're kind of trying to get to, called confidence intervals and hypothesis testing, which is a really big idea in statistics, how we test our hypotheses about things that we want to look for in data. All right, so first thing I'm going to do is just label what I'm given. We were given an average, so that's a mean. 22 and everything's hours per week here. Okay, and then standard deviation I was given. That was 9 hours per week. We are finding the probability that that student, we're selecting X, works less than 4 hours, whatever their hours that they worked are. Okay. So it also tells us that it's normally distributed. If we didn't know it was normally distributed, we couldn't use our bell curve information. We wouldn't be able to use this chart. So you're always going to see that in there somewhere. All right, first thing we need to do is convert this x score into a z value. The x score is less than 4 that we're worried about, but we're going to use 4 to figure out where that z score is, where that area is going to stop at when we actually get this graph. So calculating the z score. Okay, I'll write that formula down for you one more time. It's x minus the mean divided by the standard deviation. My x value that we're equal to, greater than, less than, whatever it happens to be here, it's less than, is 4. Minus my mean divided by my standard deviation. So that's going to give me a negative 18 over 9. And this one's actually nice and pretty. It's a negative 2. Okay. So this problem, find the probability that x is less than 4, is the same as find the probability that you have a z-score less than negative 2. Okay, and now that looks like the problems that we just did a second ago. So we're going to find negative 2 on our chart. And if you need to, draw the picture. Negative 2 is down here somewhere. Less than, so it's the area to the left that we're looking at. Negative 2.00 is 0.0228. And then find the probability. You can leave it like that, or you can leave it as a percent. It's telling us there's about a 2.28% chance that a student selected at random will work less than 4 hours per week. Okay, so we take our x value, we convert it to a z-score. We use a z-score to find the probability on our chart. Less than, we didn't have to do anything here. If it was greater than or between, you'd have a little calculation like we practiced last week. Make sense? Okay, let's do one more together. A survey indicates that for each trip at a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store are normally distributed and are represented with the variable X. Shoppers enter the store. A, find the probability that the shopper will be in the store for an interval listed between 22 and 52. And then also we're going to do more than 37. And then it says when 200 shoppers enter the store, how many would you expect to be in each interval? So after we find the intervals and the probabilities, we'll come back and deal with that. All right. What is my mean? Mean is 43 minutes. Yep. Standard deviation? 12. And all of these are X values that we're going to have to deal with over here. Okay. So I'm going to kind of do all these problems at once here. I'm going to take each of these X values and I am going to convert them to a Z-score because I'm going to need the Z-score to find the information on my chart. All right. So to calculate the Z-score, my X, 22, minus my mean, 43, divided by the standard deviation of 12. This one I don't think works out pretty. No, it does not. If you need to, we're going to round to 2 decimal places. We don't need to here. Negative 1.75 was an exact answer. Okay, then we're just going to keep changing that X value. This time make it 52 minus 43 over 12. .75. Again, no need to round. If you did, 2 decimal places because that's all we have on our chart. And then 37. 37 minus 43 over 12. I get negative 0.5. Okay. So once I have a Z-score, I'm going to find the cumulative area on my chart that goes with each of those. And you can label it with an A if you want to keep everything kind of straight where all these numbers are coming from. Cumulative area, area to the left of each of these values. All right, so negative 1.75 gives me 0.0401. 0.75 gives me 0.7734, and negative 0.5 negative 0.50, finding on here, 0.3085. Okay, good finding all that info. Taking all the X's, converting them to Z-scores, getting the associated probabilities areas. All right, so for number 1, we want between 22 and 52, which ends up being between these 2 Z-scores, which means being the difference between these 2 areas. And remember, it's always just biggest minus smaller. So 0.7734 minus 0.0401. And I get 0.7333, or you could say 73.33%. So the probability that any given person's shopping trip that's selected is between 22 and 52 minutes. It's about a 73% chance that it will fall within that range. Number 2 was more than 37 minutes. Okay. If it's more than, what do we have to do with that area to adjust it? More than is to the right. Yes? So if it's to the right, right now I have something that's to the left. That's the only thing my chart gives me. What do I do with it? Just 1 minus is all we have to do on this one. You have to do the complement. 0.3085, I get 0.6915 is my answer there, or 69.15%. So the probability that, again, a person's shopping trip is selected, that it would be a shopping trip that is longer than 37 minutes would be about a 69% chance. Okay, so those are the first part of our answers. Find the probability that each of these things would occur. Second part of the question said, when 200 shoppers enter the store, how many would you expect to be in each interval? So this problem's easy now because I already have the probability. If I know that approximately 73% of shoppers fall in that interval between 22 and 52, and now I know there's 200 shoppers, all I have to do is multiply that by 200. And that's going to tell me about how many people out of the 200 fall in that range. And that is, I'm just going to round to the nearest person. I get 146.66. So I'm going to say about 147 people. Oops. If I can make that wider. There we go. About 147 people. So my two answers, why does it keep doing that? I don't like that. There we go. 73.33 and the 147. And then you can do the same thing for this one. You can multiply by 200 to figure out about what that means in terms of how many people shop for that long. I get 138.3, so about 138 people shop for longer than 37 minutes. Okay? Make sense? All right, the last one on your paper is yours to try. I'll give you a couple minutes. I think we'll put answers on the board of some kind here, so I'll let you know in a minute. I can make sure I actually freeze it this morning. Yep, we're good. All right, go ahead and try it, and then we're not going to worry about the back of the paper today. I may or may not do that, or I might give you another sheet. I don't know. Okay, this is perfect. What questions do you have? Okay, so some reminders. Your 5-1 Math Excel is due tomorrow night. 5-2 Math Excel is due on the 19th, so Wednesday night. We were going to have a Math Excel Wednesday workday. Now it's going to be on Friday, so we're pushing that back just a little bit. You'll notice in the WAG when you log in to Polaris that that's been changed. All right, you have an exit ticket for this section. It is due in Polaris before you return to class tomorrow. Probably get it done right now, or you can do it at home tonight. That's up to you. The first problem, like the first 5, are very similar to the empirical rule type questions that we did back in chapter 2, where you're going to label the axes, that what number is 1 standard deviation out, 2 standard deviations out, and then use that information. Numbers 6, 7, 8, and 9. And 9's a little bit of a challenge type question. Are more like what we did today. Okay, but some of those empirical questions might be a little bit easier with your z-score formulas and things that we practice. All right, so for that first problem, you are just labeling the x-axis with whatever the mean is going to go in the middle, and then you're going to count out not 1, 2, 3, but whatever 1 standard deviation is going to go to the right. Whatever 2 standard deviations is going to go another unit to the right. Does that make sense? Remember how we did that back in chapter 2? Okay, perfect. All right, I'll do Salvo and Lotto. You've got 20 minutes now. Again, this is due in Polaris before you return to class tomorrow. But you can get done now if you want. You can work together if you like. That would be great. Divide and conquer, whatever you like. Salvo and Lotto winner is 29. Big spit.